Today, I will guide you through the world of microcontroller programming with Ruby. My name is Hasumi Kin. It's a great honor to be a part of Euruko. Thank you very much. Microcontrollers are now the brains behind countless electronic devices, from household appliances to robotics or even satellites in the space. And today, I'll show you the very first steps of connecting the power of Ruby to microcontroller. Here's what we'll cover in this session. Part 1, preparation. Part 2, getting started with microcontroller. Part 3, exploring PicoRuby further. Part 4, PicoRuby under the hood. But before that, let me introduce myself. My name is actually Hitoshi Hasumi. Hasumikin is an internet name. I am the creator of PicoRuby and the PRK firmware that I'll mention later. And I'm also a committer of CRuby's IRB and Reline. I was the first prize winner of Fukuoka Ruby Award in 2020 and in 2022 twice. And lastly, I was a final nominee of Ruby Prize 2021 due to PicoRuby. So let's get started with part 1. We will cover the essentials you need to get started with microcontroller. You need these stuffs, a Raspberry Pi Pico, or other RP2040 based controller. I will explain what is it later. And the USB cable and a terminal emulator on laptop. In short, buy a Raspberry Pi Pico. That's it. Raspberry Pi Pico is a microcontroller board whose MCU is RP2040, which includes Cortex M0 Plus dual core and 264 KB of RAM, 2 megabyte flash of ROM. It generally runs without an OS, so-called bare metal. On the other hand, the famous Raspberry Pi is a single-board computer. It generally needs an OS like Raspberry Pi OS or Windows 4 ARM chip. And terminal emulator, the popular options include GTK term for Linux and Terraterm for Windows, made in Japan, which is very nice. I'll use in this today. And I think PuTTY works for macOS. I'm not sure, but it should work. Some traditional CUI/TUI tools may have line feed trouble, so I recommend GTK term or Terraterm or PuTTY. So let's begin. There is 4 steps. Download the latest RP20 UF2 file from GitHub. To be exact, you can download zip file from my GitHub page, and you should unzip it. And by the way, R2P2 stands for Ruby on Raspberry Pi Pico. Someday I'll control that robot. Step 2, connect Pi Pico and PC while pressing the boot cell button. So you should find RPI RP2 drive automatically in File Manager, which is File Explorer or Finder in Mac. Then drag and drop R2P2 UF2 file into RPI RP2 drive. UF2 means Universal File Format, I think, developed by Microsoft, which is easy to handle, communicate between different platforms. It's a kind of binary file. Then open a proper serial port on terminal emulator. Let me do it. This Raspberry Pi Pico is already installed our UF2 file, so I just maybe restart. Here comes Pico Ruby. Thank you. R2P2 shell should start. Yeah, this is a Unix-like shell running on Raspberry Pi Pico. Note that every computing calculation is happening on microcontroller, not on my laptop. My laptop is just a terminal emulator. For example, there's a file system, so I can hit ls command, pw where I am, things like make directory, my dir. So ls with option L, and oh yes, red one, irb. Pico Ruby's IRB is running within the R2P2 shell on Raspberry Pi Pico. Your Ruby snippet is compiled into mruby VM call and executed on the fly. Let me show you. Put S, hello, hello. It means Pico Ruby contains mruby compiler, which can run on a one-chip microcontroller. I will explain the aspect of technical. But yeah, here you are prepared to get started with microcontroller. So let's dive into deeper more from now on. First, you need to know GPIO, which is General Purpose Input Output. GPIO is the most fundamental functionality for digital operations. You can use GPIO to detect switches or buttons state, whether it is on or off in input mode. If you change GPIO into output mode, you can, for example, light an LED by creating voltage. What the GPIO means to microcontroller is just like what the STD-in, standard in-out, means to a Unix computer. By the way, do you use debug print? Yes, debug print is the ultimate method, right? Yeah. Likewise, you can see the internal status of microcontroller by blinking LED. For example, blinking fast indicates something going wrong in microcontroller. So in this mean, microcontroller's GPIO is very fundamental one. So please remember this one today. And let me show you a demo. LED equal GPIO new 25 pin, GPIO 25 connects to onboard LED internally on Raspberry Pi Pico. GPIO out. LED right 1. What will happen? Oh. If you write 0, turned off. So what will happen? Of course. Thank you very much. This is how R2P2 shell and IRB works. Yes, but it feels like kind of magic. What is happening behind the scene? To explain it, this is the equivalent circuit. You can make a blinking LED by discrete parts instead of using onboard LED. You need one LED and one resistor, which is 1 kilo ohm in this case. I don't do a demonstration for this, but for example, in this case, GPIO pin 15 connects to resistor. Then current flows this line and returns to a ground pin. This is essentially equivalent what you saw before. And this is the calculation. RP2040's logic level is 3.3 volt. Then LED voltage drop should be 1.8 volt according to LED's data sheet. So you should read that sheet. Then current will be 3.3 volt minus 1.8 volt divided by 1 kilo ohm equals 1.5 milliampere, calculated by Ohm's law, famous Ohm's law. Now we are taking study time, and today's lesson is physics. Ohm's law represents the relationship between three values, which are V stands for volt, I stands for current, R stands for resistance. So that's why you can get the result of 1.5 milliampere. 1.5 milliampere determines the brightness of the LED. If you raise this up, for example, 10 milliampere, the LED should blink very bright. Then, if you want blink more darker, you can use bigger resistance in order to make the result of ampere smaller. Then another thing you should know is Kirchhoff's circuit laws, which is current laws tells the algebraic sum of currents in a network of conductors meeting at the point is zero. Voltage law tells the directed sum of the potential differences around any closed loop is zero. Do you understand? Okay, let's go further. Next, ADC. This is another famous peripheral, analog to digital converter. While GPIO's possible values are only 0 and 1, because it is digital. But ADC can handle values in between by converting analog voltage to digital voltage. For example, RP2040's ADC has 20 bits depth and accordingly takes a raw value from 0 to 4095, which means 3.3 volt. And typical usages of ADC should be temperature sensor and joystick. You use every day, right? So let me show you the example. Require ADC new temperature. Require ADC new temperature. And for example, ADC read raw value, read voltage. It is 0.7 volt now. Then while true, V equal ADC read voltage and put S, magic number 27 minus V minus V minus 0, 6. Channel. Oh, sorry, this is too fast. This is the temperature of the chip. So if I hold the chip by my finger, the value should raises. What? Something I might miss it? Yeah. Now it is 19 degrees in Celsius. But, it doesn't write. Oh, yeah, slightly. But actually, I don't recommend to use RP2040's on-chip LED in practical usage because it is very kind of cheap functionality. But for today, it's enough to explain, right? So it's working. Go further. As in, you can create temperature sensing circuit by discrete parts with resistor this is, and thermistor. In this case, this thermistor is kind of a resistor whose value varies according to the temperature. This, for example, this thermistor should indicate 10 kilo ohm at 25 degrees. This is the circuit. And this is how can you write the thermistor program. I don't demonstrate today, but this should be working. Okay. Next, part 3, exploring Pico-Ruby further. We'll take a closer look at Pico-Ruby applications and explore its capabilities. Two major applications exist for Pico-Ruby. I wrote both. One is R2P2. It is a Unix-like shell system written in Pico-Ruby. You may want to say on operating system in the Ruby. And PRK firmware, it is a keyboard firmware framework for DIY keyboard. You can write your key map and keyboard behavior with Ruby. Actually, I'm now using my DIY keyboard running with Ruby. Oh, thank you. What a warm community. And R2P2, multiple line editor, yeah, you already saw. There's a multiple line editor working in IRB, like C with IRB, because I am IRB's maintainer. But the code base is quite different. Any common code doesn't exist. And there are some built-in commands and executable, all written in Ruby. You can write your own external command, like, yes, for example, date. Date. Oh no, it is IRB. This is shell date command. This is the very epoch. Because I turned on the microcontroller 14 minutes ago, right? But you can see it is working. Make deal, as you thought. Time now should be the same, fundamentally. So date command located in bin directory. This is cat date. What will this show you? Cat. Cat bin date. It's a kind of binary file. This is a compiled VM code, pre-compiled one. So you can see name of the creator of Ruby, right? And some words you're familiar with: time, now, to s, put s. And furthermore, you can use a text editor. Hello, RB. Oh. Hello, RB. Insert mode. Put S. Oh, it is not working. What is happening? I think name is bad. Oh, crashed. Yes, hello RB already exists, so let me remove it. Then, vim, hello RB, put S, hello, Euruko, escape, clone, W, Q, and execute. Hello, Euruko. But that text editor is still poor functionality and many of bugs, and so you may want to write your script with your usual text editor, right? You can do it, yes. For example, you can just drag and drop into home directory. I skipped the fact that R2P2 drive should automatically mount it when you connect to through the USB to the computer. So you can see the home directory like this, my dear, which I made earlier, and the hello RB I wrote just right before. Maybe, yes. I don't want to write this code now, so GPIO and the ADC work together. It should be GPIO and ADC. Yes, this is. I think this should be working. GPIO and ADC drop into home directory. So you can find GPIO and ADC .rb, GPIO and ADC RB. Already blinking because it is, The program was, if the temperature above than 19 degrees, the LED should turn on. That's why that LED is turning on, but you may want, yeah. As you can see, it is working. properly. Thank you. And furthermore, if you make home/app.rb, this RB file should automatically run on startup. Let me show you. App.rb. Firstly, made a GPIO instance, which is direction is output, and the pin number is 25, connects to onboard LED, and next making while infinite loop. Then I put this hello world and blinking LED. So let me drag and drop up RB. Of course, you can see the file APPRB. Then I will turn off the power. And turn on. In this way, you can easily create an IoT system, right? With only Ruby. You should not write C, nor Rust. Of course, Go. Gone. Go is gone. Okay, we have some additional time. Yeah. Let me explain some other peripherals, which serial communication protocols, SPI, I2C, and UART. Today, I skip the details of these protocols, but you should use one of these protocols to communicate with devices, things like altitude meter or BLE module or LTE 5G module. I already wrote the library for those three protocols, so you can try it out. This is another example of I2C, I2C, which is a serial communication protocol. The blue one is an RTC module, can have a small battery, so it can long rest the time. If you turn off the microcontroller, even if you turn off the microcontroller, RTC keeps the actual time, current time. So this is how you can make date command everywhere, right? Yeah, this is just a photo. My another keyboard, which is coordinate. Maybe some of you are using this keyboard, right? Okay, one, just one? Oh, you should. This is the example of keymap.rb of PRK firmware. This is not for coordinate. This is for Mage2, which has only 4 keys macropad. This is for example to see easily. This is one layer. You can switch another layer. This example has 3 layers. This is how the DIY keyboard, which has less than 50 keys or even 30 keys, works. Okay, finally, we go through the Pickle Ruby under the hood. We should, we are, we are taking a look at deeper into Pickle Ruby. As you may know, mruby is a general-purpose embedded Ruby implementation written by Matt himself. And Pickle Ruby is written by me. It is another implementation of mruby targeting on one-chip microcontroller dedicated for smaller footprint. But the mruby's VM code standard is exactly the same. So you can use your VM code compiled by mruby compiler can run on Pickle Ruby and vice versa. Pickle Ruby compiler's VM code can run on mruby virtual machine. This is about the small footprint. Valgrind is a memory profiler. Then if you write Valgrind option tool massif option stacks equals yes, and which includes stack memory profile in addition to heap memory, then subcommand should be passed to mruby or Pickle Ruby. This is very familiar with you. Evaluate option protest hello world. This command will generate a massif out process ID file. Then you can see the result ms underscore print command with passing the result file and pipeline less. This is the example of the real result of mruby's RAM consumption, which consumes 168 KB. On the other hand, Pickle Ruby less than 10 KB. This is why Pickle Ruby can run on one-chip microcontroller. Yeah, same thing. All small application. Thank you very much. And only small applications written in mruby should work on RP2040 because it can compile protest hello world and execute it consuming 168 KB. But bigger application cannot run on Raspberry Pi Pico in mruby. But you can R2P2 and PRK firmware is quite bigger application written in Ruby. They are working on Raspberry Pi Pico, which has 264 KB of RAM. And there is Pickle Ruby ecosystem, which is PicoGems forked from MGEM's Matt's world. So that's why we can use require ADC. And I wrote these peripheral libraries so that you can start with today, right? And there is peripheral interface guide to write porting to other microcontrollers easily. Yes, the same. But there's some restrictions of Pickle Ruby, minimum built-in classes and methods, and it doesn't support some syntax like a here doc, and it doesn't support module. It is similar to MicroPython's restriction. MicroPython doesn't support maybe meta class and multi-inheritance, yeah, which is very similar. And conclusion, Pickle Ruby is a Ruby implementation targeting on one-chip microcontroller. You can develop your microcontroller application step by step using the R2P2 and IRB. You need only R2P2 to run small applications. And future work of mine, BLE, I'm writing now BLE library and Wi-Fi with Raspberry Pi Pico W. This should be launched soon. And porting to microcontrollers other than RP2040 someday in the future. Yeah, here's quick advertisement from Japan, as Shibata-san does. Coming May, Ruby Kaigi 2040 will happen in Okinawa. I really encourage you to visit Japan this time. And that's all. If you feel my talk is fun, please visit. Please shoot the QR code, and there are 4 repositories. PicoRuby is the Ruby language implementation. R2P2 is the shell system. PRK firmware is the keyword firmware. This is peripheral demo application. Please stargaze them. Yeah, that's it. Thank you very much.